Welcome back to another lesson about functions and graphs. In today's lesson, we're going to learn about quadratic functions. We will learn how do the parameters of the quadratic equations affect the parabola. Let's get started. We will start with the equation y equal to ax squared plus bx plus c. And from this equation, we're going to know the effects of a, b, and c. And then we will know what this equation means. So we will start with the most basic equation, which is y equal to ax squared. We'll have x and y. So we'll have minus 3. So we're going to plug minus 3 to y equal to x squared, and we'll have 9. And here we'll have 4, we'll have 1, 0. This will be the same as on the negative side. This is 1, this is 4, and this is 9. And then we'll take this and draw it here. So for minus 3, we have that point 9. And for minus 2, we have 4. For 1, we have 1 here. And that is the graph for y equal to x squared. Example number 2, we're going to increase the value of a to a is equal to 4. And now we're going to have y equal to 4x squared. We do the same thing here. We evaluate what is y when x is minus 3. When x is minus 3 squared is 9. 9 times 4 is 36. So you do the same for the other ones. Minus 2 squared is 4. 4 times 4 is 16. And this is going to be 1 squared. 1 times 4 is 4. This is 0. Then you take the same for the other side. I want us to draw this on the same set of x's so that we can see what is going on. So let's draw y is equal to 4x squared. My drawing is terrible, but it's something like that. That's the shape. So that is 4x squared. So we increase the value of a to be a equal to, okay, we decrease it now because we've increased it from 1 to 4. So we can take it to 1 over 4 when it's less than 1. So we want to see when a is smaller, what happens. So when a is 1 over 4, y is equal to 1 over 4 x squared. So we're going to evaluate the value of y when x is minus 3. So when it's minus 3, x squared is 9. Then it's going to be 9 over 4. This is going to be. So we're going to draw this. Okay, we can change this to see what's going to happen. 9 over 4 is 2.25. So we can take another color to see what is this going to look like. So our parabola is going to be something like that. Okay, we can continue with the shape. So that is that. So we go smaller. So we have a is equal to 1 over 4. And now when a is equal to 0, what happens? So when a is equal to 0, we have y equal to 0. So when a is equal to 0, we no longer have a parabola because we're going to have a line that is y equal to 0. So we can see that we can conclude and say a cannot be equal to 0 because when a is equal to 0, we no longer have a parabola. And we can also see that as the value of a increases, the shape of the parabola is getting steeper or narrower. You can see that this value was 1 over 4. This one is 1. This one is 4. So as the value of a increases, the shape is getting steeper. The parabola is getting steeper or narrower. What happens now when a is negative? We'll start with the same equation, which was y equal to x squared. But we'll make a, so a in this case is negative 1. So we'll still evaluate it the same way. So minus 3 squared is 9. So we have minus 9. So we're going to draw this the same way we did. And we have that shape. We will see it later visually on a better scale. This is just poor. But I just want you to see what is happening. So we can see this is the same. This graph is the same as this one here. Just that now y is negative. So we continue with the same thing. You can see that we're just going to be a reflection. So the second example was y equal to 4x squared. So now it's going to be minus 4. So we can take the graph, this one, which was 4x squared, and then we just take it to the negative side. I can't draw, so you're going to forgive me for that. But yeah, that's what it's going to look like. And then we take another graph, which was y equal to 1 over 4x. So it's going to be minus 1 over 4x squared, which was the white one. So we can see it's going to be like that. We can now make our conclusions that from what we've seen, we know three things. When a is greater than 0, we have a concave up shape of a parabola. And when a is less than 0, we have a concave down parabola. And when a increases, the shape of the parabola gets steeper. So you can see that the effect of a has nothing to do with your intercept or where your turning point is. It just has to do with the shape of the parabola. So I'm going to show you visually what I'm talking about, since my graphing skills or my drawing skills are terrible. Okay, so I am showing you with a better view now. So we started with y equal to x squared and a was 1. So this is the value of a. So I'm going to increase the value of a and you can see what's going to happen. So as you can see, as I increase the value of a, the graph is getting steeper. We had a equal to 4. So you can see it's getting steeper and we can continue increasing, it's getting more steeper. And then as we decrease the value of a, it's opening up, you can see. And when a is equal to 0, like I said, we do not have a parabola. We just have a line, which is y equal to 0. And now that is a straight line. So a cannot be equal to 0. And then, look now what happens when a becomes negative. You see, immediately when a becomes negative, the graph concaves down. So it changes the shape. Again here, as the magnitude of a increases, it's still getting steeper. Nothing changes. It's just that now it's on the negative side. So we can see what happens with the value of a. So we can keep doing that and you can see what happens. So we know now what is the effect of a on the parabola. Now that we have evaluated the effect of a, we're going to build it up and evaluate the effect of b on the parabola. So we had our basic formula, basic equation, which was x squared, and when a was equal to 1. So we're going to build it up from there, and that is the graph. So I'm going to show you from this basic graph what is the effect of b on the parabola. So we're going to add plus x. So in this case, b is also equal to 1. So we're going to build it up the same way. We're going to draw the graph of y equal to x squared plus x. And then we're going to substitute. And we have here 9 minus 3 is 6. 4 minus 2 is 2. And 1 minus 1 is 0. And this is 0. And then 1 plus 1 is 2. and 4 plus 2 is 6, and 9 plus 3 is 12. So we have those points. So we're going to take these points and draw them here. We cut here, and then we cut somewhere there. So what happens here? So we have a turning point there, but we do not know where, but between -1 and 0. So this is y equal to x squared plus x. So can you see what happened here? You can see that, okay, we can talk about this point, the turning point, right? You can see now that the turning point shifted. It's no longer at 0 is to 0. It's at this point that we're going to have to calculate. So you can see that it shifted to the left. So we can already see the effect of adding b onto the equation, that when we add b, we are shifting to the left. We're going to have b as negative and see what happens. So now we have b equal to -1, and our equation is x squared minus x. We do the same thing. And we can now take this and draw. So to make things quicker, because we can see that the numbers swapped, that means we're just going to shift everything to the right. So and our graph is something like that. That means our turning point is somewhere there. I hope you can see this, because my sketching skills are not perfect. So now we want to see, we have b equal to +1 and we have b equal to -1. So I want you to note this. So when b was equal to positive, this is b equal to positive. And then this is b equal to -1. We can see that from the basic graph that we had, which is the yellow one here, we shifted to the left when b was positive, and we shifted to the right when b was negative. So we can see the effect of b, that it shifts your graph horizontally. It's either going to go to the left if it's positive or go to the right if it's negative. So now what we can see that is that the turning point is no longer at point 0 is to 0. So from the graph, the basic graph that only has a, right? The basic one, which is x squared, y is equal to x squared. We can see that our turning point is always equal to that point, which is 0 and 0. And now we can also see that here it has shifted. It has shifted from there, from that point. So we can tell that, oh, the value of b also has an effect on the turning point. So how do we get the value of the turning point now? We can calculate the value of the turning point using the gradient. So from the formula, we have y equal to ax squared plus bx, right? And we can find the gradient of this using a derivative. So we're going to have y dash is equal to 2ax plus b. And the gradient at the turning point is equal to 0. So here we're going to have 0 is equal to 2ax plus b. And then that's going to give us the x value is equal to b over 2a negative. So now we can see that the value of x at the turning point is x equal to minus b over 2a. So we can use this equation to calculate the turning point. Another thing to note is that what is it exactly that we shifted with the value of b? Okay, we said the turning point, but another word that you can use is that you can see that from this graph, which is y equal to x squared, that the axis of symmetry is x equal to 0. you can see that this side is the mirror of that side at this point. But now that we shifted the graph, the axes of symmetry are also shifting. And now the axes of symmetry are at the x value of the turning point, which is x equal to minus b over 2a. And that is that point. So the value of b shifts your axis of symmetry either to the left or to the right. And I'm going to show you visually as well what is happening, the same way I did for the value of a. So this is our equation, y equal to x squared. But at this point, you can see that b is still 0. So b is still 0. We're going to shift the value of b. I want you to look at what is going on the graph. So we're shifting the value of b. You see, we are shifting it to 1. So let's put it to 1. So you can see that your turning point, your axis of symmetry is turning. And another thing to note now, you can see it nicely here, is that you are also introducing an x-intercept. Remember when b is equal to 0. Look at when b is equal to 0. You see, you only have x-intercept, which is x equal to 0. But immediately you introduce b, you have another intercept other than x equal to 0 that is introduced by the value of b. So we can say that, okay, we are shifting the axis of symmetry and we also have the impact on x. So the value of b has an impact on x-intercepts as well. So as we increase the value of b, look at what's happening. You see, we're changing the axis of symmetry. We're changing the axis of symmetry, which is a turning point as well. And now what happens when b is negative? We are shifting to the right, and the axis of symmetry also changes, which is the value of the turning point. Note one thing here. We haven't spoken about the y-intercept. Look at the value of b. The value of b has nothing to do with the y-intercept. That part you should note. It has nothing to do with the y-intercept. The only thing that it influences is your turning point and your x-intercept. Because you can see here, the only thing that changes, you see, you are changing your turning point and your x-intercept. So the influence of b is on x and your axis of symmetry. Now, we're going to evaluate the effect of c on the basic parabola. So we had a x squared. Okay, a was equal to 1. So we want to see what happens when we introduce c. I want to introduce c on this equation. It's still going to have the same impact on the ax squared plus bx. But I'm just going to show you on this. And then when I'm showing you visually on the software, you would see I'm going to add it onto the bx as well. So, but it's going to be the same. So let's get started. So we have y equal to x squared plus c. So we want to see the effect of c on your parabola. And so we're going to take c equal to 1. So we have y equal to x squared plus 1. And we can do the same thing here. And we take these points and we draw them. Okay, so we have our graph as the white one there. Okay, it's not in scale. I won't keep saying this. But you can see that every point shifted by 1 unit up. So now we have a y-intercept. Our graph is cutting at the y-axis. So from this point already, you can tell that introducing c, our graph is shifting up. So we're going to do the same thing when c is negative and we can see what is going on. So c is going to be equal to minus 1. So when c is negative 1, okay, we change that, now it's negative, we can see that the values changes as we expected, and we can take these values and we draw the graph of x squared minus 1. Now we can see that we have a y-intercept of y equal to minus 1. And we can already see that the graph has shifted downwards. So to conclude from here, we can say that the c value is responsible for shifting the graph upwards when it's positive, and it can also shift it downwards. So this is when it's positive, and this is when it's negative. So it's for a vertical translation. And it also introduces a y-intercept. So when you have a value of c, you're going to have your y-intercept, and your graph is going to shift up or downwards. But look at this. The value of c has nothing to do with your axis of symmetry. You see, your axis of symmetry hasn't shifted. It's still x equal to 0 because we do not have the value of b. Even if we have the value of b, the y-intercept will not have anything to do with the axis of symmetry. The only thing that it will do, it will shift the turning point upwards or downwards, but it won't shift the horizontal translation, because the horizontal translation is for b. So let me show you this as well on the software. So what happens now when we change the value of c? So we're going to make c, which in this case is b, positive 1. So you can see the graph is shifting upwards. So when it's 4, your y-intercept will be 4. And then when it's negative, it shifts downwards. So you can see that c has nothing to do with a and b. It only shifts the graph vertically, upwards or downwards. So now that we know the effect of a and b and c, I want to give you a quick example. Like, you're going to sketch it. I don't know how to say it, but you're just gonna sketch it from the values. You're not gonna draw the table. I just want you to know that you are able to see from the equation how the graph is gonna look like. So this is the example. You have f of x, equal to x squared minus 5x minus c. So you have the value of a equal to 1, and the value of b equal to minus 5, and the value of c equal to minus 6. So from here, I want you to already see what's going to happen to your graph. So you can pause the video and do this and then come back to it. So this is how we're going to do it. We won't sketch this out. Just want you to have a visual graph on your head, how it's going to look like. Okay, you already see that, oh, my a is equal to 1, which is positive. Therefore, my graph is concave up. So I already know that I have a concave up graph. And then I have b minus 5. Okay, so now the axes of symmetry are no longer at 0 is to 0. No longer at x is equal to 0. I have a new axis of symmetry, but I won't calculate it. And my value is minus 5. So this means that this is responsible for horizontal shifting. And when it's negative, I'm shifting to the right. So I already know that my turning point and the axis of symmetry are somewhere on this side. But I will have to calculate, but I don't want to calculate. And then I already know that, oh, okay, I also have c is equal to minus 6. That means I have a y-intercept of minus 6. So that means I'm cutting my graph here. So from the original graph that was like this, you saw, oh, okay, I translate minus 5 times. Okay, this is not going to be directly minus 5. You can use the equation x is equal to minus b over 2a. But we won't do that. And then you also see that you have a y-intercept. And then you can draw your graph. So your graph is going to be something like that. Because you have your y-intercept here, you know that your turning point has shifted to the right because of b is equal to minus 5, and you also know that your graph is concave up. So let's see if we got the shape correct. So this is your graph. This is your equation, y equal to x squared minus 5x minus 6. So you can see now from the equation, you can already tell how your graph is going to look like. This is also going to help you when they said evaluate the value of A. What is the value of B? What is the value of C? So when you have a graph that is concave up and then you get your value of A as negative, you should already know that you've done something wrong. So you have to go back to your steps and correct it so that you can get a positive value. So this gives you an insight of how your graph should look like. So this is good for you to understand. So now we fully understand the equation y equal to ax squared plus bx plus c. So what is this equation called? This is the standard form of the parabola. So this is how you represent your parabola in a standard form. In the next video, we will also do the turning point form and also the x-intercept form. Thank you for watching. Please do comment down below on what you would want to see on other videos. I would really appreciate that, and I will see you on the next video.